Okay, so I'm going to start doing my exam prep PowerPoint slides on this now. Apologies if you're hearing the football in the background. PSG are currently smashing Liverpool. Um, anyway, so I'm going to go through this. I'm going to skip the bell work and I'm just going to read all the information that I have provided you over the last few weeks. Okay, so raw materials. Raw materials is the phrase used to describe the basic materials that are either removed from the ground, so for example, oil, stone, or grown, such as wood. Wood. Wood is extracted from trees. Depending on the type of timber, they are commonly categorized into three types. You've got softwood and coniferous. Hardwood or deciduous. You've also got manufactured wood. Metals. Metals are extracted from the earth as ore. To extract the metal from the ore, it must first be smelted. Smelted is the process of using a blast furnace to apply very high temperatures and chemicals to the metal ore. This process enables the extraction of the metals. In this example, you can see how iron is extracted from iron ore. The extracted iron is known as pig iron, a type of crude raw material. Pig iron is not particularly useful for products as it has a very high carbon content and it is far too brittle for any practical use. Pig iron needs to be refined further, reducing the carbon content into usable metals such as steel and cast iron. So the main ingredient of plastic is crude oil. Crude oil is made from trapped fossils under sedimentary rocks, and over thousands and thousands of years, with the Earth's pressure, it becomes either coal, oil, or natural gas. So plastics can be sorted into two groups. You've got thermoplastics or thermoforming plastics and thermosetting plastics. Thermoplastics are things like bottles and food packaging, things that we use on a daily basis. Thermoplastics are really easy to recycle. They can be remelted and turned into something else. This is because of the weak bonds between the chains. And as the image demonstrates here, when you heat thermoplastic up, it starts to melt. And once it's at that melting, malleable stage, you can change it into something else. So the bottle here changes into a yogurt pot. That yogurt pot can go back into a bottle, and so on. So if we take a closer look at thermoplastics in its molecular level, you would see tangled polymer chains. Now they're not stuck together, they're not held together by covalent links, they are just tangled, very similar to spaghetti. There are no cross links between the chains. There are weak forces of attraction between chains, which means that they can be stretched and pulled into almost any shape, and it softens when heated. I want you to think of thermoplastic polymer chains like a bowl of spaghetti. The spaghetti are tangled and placed over one another, but they are not stuck together. This is very similar to thermoplastic polymer chains. They can be picked apart easily and manipulated into a different shape. Thermosetting plastics. So things that are more hard wearing like light switches, plug sockets and remote controls. Thermosetting plastics are quite difficult to recycle. When you try to melt these down, they just burn and turn black, or turn black and burn. This is because of the strong bonds between the chains. So if you try to heat it up with a high temperature, it's non-recyclable, it releases toxic gas, and it will just absolutely fail. So taking a closer look at this in a molecular level, polymer chains are held together by strong covalent cross-link bonding that does not break on heating, meaning that they are stuck together. They form like a 3D shape or a net. It remains hard when heated. This is the problem. This is why we cannot recycle thermosetting plastics. So I want you to think of thermosetting plastic polymer chains like making jelly. To make jelly, you must place jelly cubes into boiling water, let it dissolve, and then place the mixture into the fridge. Once the mixture has cooled, you will have jelly. Now imagine trying to change that jelly back into its original state. Is it possible? No, it's not. This is very similar to thermosetting polymer chains. Once, it, once they have taken shape, they can't be changed back. Once it has set, it's set, meaning the name thermosetting plastic. Okay, so which type of plastic do you think is better for the environment? Well, it is thermoplastics. Why? Because they're recyclable. This is because of the weak bonds between the chains. So looking back now on metal, ore. The Earth's crust contains many types of rock. Metallic minerals are found naturally in rock or ore. Ore is obtained by mining and the metals within it are extracted. We talked about this earlier about smelting. The method used for extraction depends on the metal's reactivity with air, water, or acids. The more reactive the metal, the more expensive it is to extract. So you can see here on the left-hand side, the most reactive metal that we have on this scale is aluminium, the least reactive, gold. So the extraction process. Some metals exist as oxides. Metals such as copper, iron, and zinc are oxides. These are heated with carbon to extract the metal. Electrolysis is used to extract metals such as aluminium. So are metals a renewable resource? They are. It is something that we can recycle and reuse. How can man reduce the speed at which we will run out of natural resources? Iron ore. Iron can be extracted from iron ore by using a blast furnace. We spoke about this earlier. And the process of smelting. Smelting extracts common industrial metals such as iron. The extreme heat draws off the metal in a liquid state called hot metal. The impurities are removed and the iron mixed or alloyed with a small amount of carbon to create steel. The amount of added carbon affects the strength of the steel. So ferrous metals. Ferrous metals contain iron and may rust. Iron and steel can corrode. This is known as rust. Rust is a compound called iron oxide and it is formed when iron and oxygen react in the presence of moisture or water. Most ferrous metals are magnetic. Name two types of protective layer that could be added to metal to help prevent rust. So you can see here on the right hand side where the chemical symbol for iron is Fe. That's where the word ferrous comes from. So if you see ferrous metal, that means that it contains iron. However, non-ferrous, which is non-Fe, no iron, non-ferrous metals don't contain iron. They are often more expensive than ferrous metals owing to their desirable properties, which include that they are lightweight, they have good conductivity, they are ductile, malleable, resistant to corrosion as well. The process of galvanizing adds a protective coat of zinc to iron and steel to help prevent rusting. Now, this is something that we have covered in metal finishes and finishes of materials. Alloys. This is the third and final category of metal. So metals are rarely used in their pure form. Alloys are made by combining two or more elements. This helps improve the working properties and appearance. Brass and steel are common alloys. Stainless steel is made by combining iron with a small amount of carbon and chromium. On top of that as well, stainless steel is also considered a ferrous metal because it is magnetic and it does contain iron. This protects the alloy from oxygen. What will this help prevent? What are the advantages of creating alloys? On the right hand side here, I've given you a few examples of some alloys. So at the top there, we've got the DeLorean from Back to the Future, which is made from stainless steel. Underneath there, we've got bronze, which is a mix of different materials, again, different metals. And at the bottom, we've got a brass instrument made from brass, obviously. So just to recap, ferrous metals contain iron. They are magnetic because of this iron compound. They rust when in contact with moisture, water, and oxygen. This is due to the iron within the metal. Ferrous metals do not contain iron. They are non-magnetic. They do not rust. Alloys are a mixture of two or more metals. They're usually made to improve a metal depending on the properties needed. Okay, now we are going to talk a little bit about the metal finishing. So we usually include the finish to metal to preserve it for as long as possible. The most common ways of preserving metal are the following. So you've got plastic dip coating, polishing, paint finish, lacquered finish, and galvanizing. We are now going to go through each process and write them down in our workbooks. Well, you are just going to listen to me talk about it. So, plastic dip coating. Plastic dip coating is a process that involves immersing a preheated part of metal into liquid plastic. This forms a plastic coat around the metal, which improves its protection and aesthetics. You can see at the image on the right hand side here where a metal is put into liquid plastic. When it's pulled out, it attracts to the metal, and there you have some tools at the bottom. So some pliers and so on, the handle, the grip on that, usually done with plastic dip coating. Galvanizing. Now the reason I put galvanizing straight after plastic dip coating because it's a very similar process. However, instead of using liquid plastic, you use melted zinc. So galvanizing is a manufacturing process where a coating of zinc is applied to steel or iron to offer protection and prevent rusting. This is a similar process to plastic dip coating, but with zinc. Polishing. The polishing machine or buffing machine is used to polish soft metals as well as plastics. Polish is applied to the mop on the polishing machine and removes dirt and light scratches from the metal. You can see an example of a polishing machine or buffing machine, whichever one you want to call it, on the right hand side. Lacquered finish. Lacquer is used on brass ornaments and finely machined steel. Lacquer is usually applied to metal after polishing to further protect the metal. Paint and spray paint finishes. Paint and spray paints in the form of spray cans can be bought straight off the shelf of most hardware stores. The paint provides a layer of protection for the metal which is required for metal items that are left or placed outside. Okay, talking a little bit more now about timber. So, softwoods. Softwoods come from coniferous trees. These often have pines or needles and they stay evergreen all year round. They do not lose their leaves in the autumn. That's the main difference. Please don't think that softwood is soft. It is not. The only difference that you've got between softwood and hardwood, or the main difference, is that softwoods keep their leaves throughout the year, hardwoods do not. They grow all year round and faster growing than hardwoods, making them cheaper to buy. And they are considered more sustainable because of this. Because you can grow a softwood quicker than a hardwood tree, it is more sustainable to use them. So if we cut a softwood tree down, plant another, by the time a hardwood tree has reached the point where we can cut it down, the softwood will have grown again. These trees are native to colder places like Scandinavia, Canada, and Scotland. Yes, we have them in England as well. However, we have more hardwood trees in England than what we do of softwoods. However, go further north into Scotland, you are going to find more softwood trees. Hardwood comes from deciduous trees which have large flat leaves that fall in autumn. Hardwoods take longer to grow, not easily sourced, and are expensive to buy. These trees are natives to places with a temperate climate like the UK and North America. So some questions here for you to answer about hardwood and softwood trees.